Alright, the time is finally here. We're going to begin looking at glycolysis. If the slide goes. There we go. So, we're going to just start with the very basic overview of glycolysis, and then we're going to look at every single step of glycolysis. And by the time you take the test, you should probably be able to do this whole chart from memory. So, let's just start at the very beginning. To get glucose in your blood, which is, remember, glycolysis is the breakdown of glucose, glycolysis. You usually get that from eating, so dietary starch or glycogen, or from storage, liver glycogen. And glucose will enter cells via various glucose transporters, GLUT1 and GLUT2. And glycolysis will take this glucose and break it apart into two 3-carbon pyruvates. During this process, we are releasing free energy because we're breaking bonds, we're removing phosphates, and we're going to use this to make ATP. And overall, there are 10 different reactions in glycolysis. And there are 2 stages. Stage 1, which are reactions 1 through 5, is an energy investment stage. Basically, it's a priming stage. You phosphorylate glucose and then cleave it into 2 molecules of trioses. This is just to get it ready for phase 2, which is energy recovery. You take 2 molecules of glyceraldehyde 3-phosphate and you convert them ultimately to pyruvate. So stage 1 is like you are putting money in. Stage 2, you're getting money back out with some dividends. Overall, the whole reaction is glucose plus 2 NAD plus 2 ADP plus 2 inorganic phosphates make 2 pyruvate, 2 NADHs, 2 ATPs, 2 waters, and 4 hydrogens. And now we're going to look at the reactions of glycolysis in depth. First reaction, take glucose, add ATP. Take a phosphate from that ATP, add it onto the 6th position of glucose. You have now made glucose 6-phosphate. So this is a transfer reaction. It's carried out by hexokinase. In the liver, the isozyme glucokinase will do this instead. And the liver is doing something else. The liver is not really doing glycolysis when it's using glucokinase. Now, the main substrate is glucose, but you need a second substrate. You need ATP and magnesium 2+, and it's in this complex. And what magnesium is doing is that it's shielding either the alpha and beta phosphates or the beta and the gamma phosphates. You're kind of hiding this negative charge, and you're drawing the negative charge towards the phosphate. This allows the OH of your C6 glucose to go and attack the phosphate of ATP and become glucose 6-phosphate. So that's reaction 1, making glucose 6-phosphate using hexokinase. Reaction 2 is phosphoglucose isomerase, taking G6P, glucose 6-phosphate, and simply turning it into fructose 6-phosphate, F6P. And if you remember, fructose is a 5-member ring. So let's take a look at this reaction mechanism. So this is carried out by phosphoglucose isomerase, PGI. Step 1, bind glucose 6-phosphate. Step 2, an acid reaction. You need to open up this ring. And we need to open up this ring because we are trying to take the 6-member ring into a 5-membered ring. Now, we don't really know what amino acid is doing this. What amino acid right here is donating the hydrogen. It's probably lysine. So we have a donation to make an OH here, and we're going to form a C double bond O. So that's step 2, this acid. Step 3, we have a base, probably histidine, taking the hydrogen from carbon 2 right here. So we're taking the hydrogen and we're forming an intermediate. We're forming the cis-adenylate intermediate. If you remember from our talk about enzymes back in Biochemistry 1, The intermediate is the highest energy step. It's the slowest one to get to, so the enzyme is designed to try and make this as favorable as possible. So once you make this intermediate, you take the proton that you just stole, you take that back, and you put it on C1 now. So instead of a C double bond O, as we had in step 2, we now have COH and a hydrogen. And we also have a C double bond here on our carbon 2. Now, if you go back to our discussions on sugars, we saw that during the cyclization of sugars, you're going to have an alcohol group attack a carbonyl carbon group. And so that's what's happening now. We have base catalyzed ring closure. This OH that we formed all the way back in step 2, the base of your enzyme is going to retake its hydrogen. That will allow this oxygen to attack, forming a ring closure. And this OH, this oxygen needs to be protonated. That's probably coming from water. So you have that protonated, and then you have your base being closed, and you have now formed fructose 6-phosphate. So those are the steps we need to know for reaction 2. And that is our isomerase reaction. We aren't changing anything about the molecules in glucose 6-phosphate. All we're doing is we're changing how they are bound to make fructose 6-phosphate. That's it for this. I will see you in the next video.